Alright, quick video guys. This is our last video on chemical reactions. We're looking at, in this video, um, 4 different types of reactions. This is a different classification system. It's not like the endothermic exothermic reaction system where we talked about whether energy was being gained or lost. Instead, this is talking about the comparison of our reactants to our products. So there are 4 different types of reaction. There's synthesis, decomposition, single replacement, and double replacement. The word synthesis or synthesize means to create, and decomposition is to break down. So in this case, a synthesis reaction takes 2 simple substances, like random element A plus random element B, that join together to create a more complicated substance, a compound AB. So an example of this would be like iron joins with oxygen gas to yield iron oxide. This is a more complicated substance than the substance that I started with. So that's all a synthesis reaction is. We take 2 simple substances, join them together to make a more complicated substance as a result of the chemical reaction. This is the exact opposite of our decomposition reaction, where we take a complicated substance, substance AB, and we break that down as a result of the reaction to create substance A and substance B separate from one another. So an example of this happening would be aluminum oxide, Al2O3, breaking down over time to produce aluminum and oxygen gas. Again, we just take a complicated substance, a complicated compound, it breaks down over time to create 2 simpler substances than what we had started with. Our next 2 classifications are a little more complicated. The first one is single replacement, and in a single replacement reaction, we're looking at like a complicated substance AB and a simple substance C. When they go through a reaction, the simple substance C kicks out one of my elements from my more complicated substance. So in this case, C comes in and replaces B. So I now have, instead of AB, I now have AC. And instead of C being on its own, B is on its own. So the element C has replaced the element B, but that was the only replacement that occurred. So in this case, example, this would be magnesium chloride joins together to create calcium, or joins with calcium and undergoes a reaction to yield calcium chloride with magnesium. So you can see that calcium from over here has replaced the magnesium from our original substance to create a new substance, calcium chloride, and leaving magnesium on its own. Our last of our reactions is called a double replacement reaction, and in this case we have 2 more complicated substances. We have substance AB and compound CD, and when they undergo a reaction, one of the elements from my compound CD replaces one of my compounds, or one of my elements from compound AB. But then the element that was kicked out of AB replaces the element that left from CD. This is a little more complicated still than a single replacement. So instead of having AB that we had in the beginning, we have AD. D has replaced B. That's one replacement. But then as well, we started with CD, but the element B has come in and replaced that D. So we have a second replacement that happens here. And you can see kind of an example of that reaction down at the bottom, where we have barium chloride, and that joins together with magnesium sulfate. And the barium comes in and replaces the magnesium to give us barium sulfate instead of magnesium sulfate. And the magnesium replaces the barium, so we get magnesium chloride instead of barium chloride. So there's 2 replacements that occur, which is why we call this a double replacement. So that's really kind of it. And looking at our notes here, so these were your definitions to put down. And if we were going to kind of look at some examples of these on the bottom, in this case I have 2 simple substances, phosphorus and oxygen, that join together to create a more complicated substance. So that would be an example of a synthesis reaction. And like this one over here is, again, we have 2 simple substances, magnesium and oxygen, joining together to create a more complicated substance, magnesium oxide. So these are just some examples to look at. Some other ones we got here. We have a complicated substance that breaks down to create 2 simpler substances, so that would be a decomposition reaction. If we look at one here, I have a single substance on its own, chlorine, and after the reaction, that looks like it has replaced my Br, and Br ends up being left on its own. So instead of having sodium and bromine combined together, I have sodium and chlorine combined together. So this tells me that I have a single replacement reaction. There's only one replacement that's occurred. as opposed to like this one here, where Cu comes over here and pushes out the H2 to create CuS. But then the H comes back over and fills back in where the Cu had left to create HCl. So that would be an example of a double replacement reaction. So we have two replacements occurring there. So those are just some examples. You can certainly fill these out, give them a try, and you can check against my answer key. There is one thing I want to make sure you add to the top, and this is a way in which we talk about compounds or classify compounds. Compounds are going to be classified as organic or inorganic, and this is a relatively complicated classification system, something you really wouldn't study in any great detail until you get to college. Maybe you might look at it a little bit in high school, but we just want to know really, really simple, and it's not totally accurate, but we want to have a basic understanding that compounds that contain carbon are generally going to be classified as organic compounds, while compounds that do not contain carbon are classified as inorganic compounds. So whenever we talk about organic or inorganic compounds, kind of a real simple, not perfect, but a real simple way to identify whether a compound is organic or not is simply to look for the element carbon. If the compound contains carbon, then we can call it organic. If the compound does not contain carbon, then we would consider it inorganic. Again, that's not perfectly accurate, but it basically sums up the material as well as we need to cover it for right now. So if you have any questions, make sure you stop by and see me. All right, have a good one.